Today, when people think of satellites, their thoughts automatically turn to NASA. But several of the early U.S. satellites were developed by scientists at the Naval Research Laboratory. This was fortunate for PSL because many of these scientists were the same people with whom PSL began its career supporting sounding rocket launches. It was only natural for these scientists to approach PSL for engineering support as they developed their spacecraft. The first major satellite that PSL worked on was the High Energy Astrophysics Observatory, or HEO for short. Bob Wagner, who retired from the laboratory in 1990 as chief engineer for the PSL Space Payload Section, was assigned to lead this project.
I designed the high voltage power supplies, 3 different types. I designed the linear A to D converter and was overall coordinator for all the other designs on board. It was quite a learning experience for us because of the high reliability requirements. All of the paperwork, which we were not used to, written procedures for almost everything you did, all of the screening requirements for all of the components that we couldn't buy as high-rel parts. We didn't do the screening, but we were involved in writing some of the specifications. Well, as I mentioned, and then of course we had to have quality assurance, configuration management. Yeah, the original the design was for a 6-month flight. It actually flew for about 1.5 years before re-entry. As far as I know, everything worked perfectly, and they got tons and tons and tons of data.
Although NASA was the sponsoring agency for HEO, PSL provided its support through a contract with the Navy. The first NASA satellites the laboratory worked on were the Getaway Special, or GAS, and the Shuttle Pointed Autonomous Research Tool for Astronomy, or Spartan for short.
On the Spartan program, we did a number of things. Largely, we designed, redesigned, reconfigured the existing technology that was used on the sounding rocket and incorporated it into a more space-qualified platform that could be flown on the shuttle. The systems that we did for NASA were the attitude control and stabilization plate, which is responsible for the guiding and pointing of the spacecraft while it's in orbit, and also the instrumentation plate, which contained a large ruggedized tape recorder for the recording of the scientific data while in flight. Yeah, we moved on to XT and TRIM, which were the full large Explorer platform-based satellites. These are satellites in the 3,500 to 4,500 pound class. On those, we did the work for NASA Goddard, Code 710. We designed and built, basically packaged in high reliability format, the attitude control system for XT and for TRIM, the attitude control system electronics. On the TRIM and XTE boxes, after we completed fabrication here at PSL, they were delivered to Goddard Space Flight Center, where they underwent environmental testing. They did the vibration and the thermovac testing back there at Goddard. They were also tested for RFI, radio frequency interference, and EMI, electromagnetic interference testing. We're real proud of the fact that these were the first boxes that had gone through that without any deviation or waiver being required.
Satellites like HEO and TRIM are not the only tools used by scientists to gaze at the stars and to study the Earth's environment. High-altitude scientific research balloons, often called weather balloons by the uninitiated, offer scientists an alternative, cost-effective platform for their experiments. High-altitude scientific research balloons using helium as a lifting mechanism are uniquely suited for performing experiments that require a point from which to view the heavens, unobstructed by the Earth's atmosphere, or from which to sample or view layers of the Earth's atmosphere at heights unobtainable by aircraft. For a cost of about $2 million, scientists can achieve 90% of the objectives achieved by a satellite costing $100 million. As an outgrowth of its sounding rocket support for the Air Force Geophysics Laboratory, PSL began providing the Air Force with ballooning support on a task-by-task basis in the late 1960s. Then in 1976, the Air Force awarded PSL a single contract to provide full-spectrum engineering and operations services. This has included payload redesign and fabrication, most notably the Department of Energy's Ashcan payload, as well as command and control and launch and recovery services. PSL's years working with the Air Force in their scientific balloon program gave the laboratory an experience base that paid large dividends in 1987. In the summer of that year, PSL was awarded a contract for the operation and engineering support of NASA's much larger balloon program.
NASA called and said you have 2 weeks to get on site for your management team to begin a 45-day phase-in. At the end of 45 days, it's yours. That's a very short period of time, but we were there in 2 weeks. The 3 top managers, we had some others from PSL come in and help us as needed. And of course, we had to interview everybody. We had to decide who we were going to hire and who we didn't wish to make offers to.
A large part of the flights were conventional flights, meaning they were less than 40 hours duration. Most of the flights end up being at 2 times a year during the turnaround periods a year. As we took over, there was the impetus to develop a long-duration balloon capability. And this project got started in the first year of our contract, where a steering committee was developed to develop the specs that we were going to use to develop the systems we needed for long-duration balloon flights. So in 1989, those specs had been put together. PSL started working on the development of the systems, and we ended up having our first LDB balloon flights in 1989 out of McMurdo, Antarctica. Since that time, the long-duration balloon program has been pretty well established and given us an additional capability that we haven't had before.
The balloon operation was one that you could, I call it, get your arms around it. You could make things happen. You could decide when you were going to fly within a given schedule, and you can make a lot of difference. Whereas on big programs like Space Shuttle and some of the rocket programs, you're just a little clog in the operation. On the balloon program, PSL was it. And NASA did their part, but when they assigned us the contract, well, they let us have a pretty much free hand as long as we all work together.
Crews from the NSBF travel the world launching balloons for scientists working for universities, private industry, and NASA. Regular launch locations currently include Antarctica, Canada, and Fort Sumner, New Mexico. Over the years, however, they have traveled to every continent on Earth. The 1970s and 80s saw PSL add business areas in electronic warfare, data acquisition systems development, space payloads, and ballooning. By 1990, 450 staff and 150 students worked for the laboratory, and contract revenues reached an all-time high of $41.4 million.